Everyone, so now we have the path selection optimization. So what is the meaning of this one? Like we told before, whenever we are calculating the metric of Eigrp, whenever we are doing the metric of Eigrp, only K1 and K3 is used. If you remember, only K1 and K3 is used. K1 is nothing but bandwidth and K3 is nothing but delay. And just now we check also, we have the formula, we make the calculation, so we are getting some number. So if you want to change the path, example, we taken one scenario, we taken one router here, one more router here, and then we taken this some network like 192.168.21.0, 12.0. Here we have one loop back. So what we will do, just we will assign the IP address here to this interface, and this IP will be here. Same thing as we do before. After that, when we check this route, we will get this route in our routing table. We will have this value because Eigrp is doing the equal as well as unequal cost load balancing. So we will get this route in our routing table. So first of all, we will take two router and we will assign this IP. How we will assign? Here I wrote the configuration. Same thing as we do from starting, just assigning the IP address, and then we will write router Eigrp1 and no auto summary network ID. What is the network ID? 21.0, 12.0. If you see here 21.0, 12.0, and if you see same thing I done here also, Eigrp no auto summary, and this two interface I advertise, and also I advertise this one. So 2.2.2 is nothing but this is a 2.2.2.0 because I am using here /24. If you see, if you use only /8, you will have only 2.0.0.0 like that, depend whatever IP you are using. And we have one more method. If you want to advertise the Eigrp for lab purpose, how we can advertise? We can advertise this way also. We can write router Eigrp1, and after that we will write no auto summary, and we will write network, and just you write 0.0.0.0. With this way also we can advertise Eigrp. When we run this command, whatever interface we have here, it will advertise that all interface here. If you see, this all interface will advertise. If you do same thing here, network 0.0.0, it will advertise all interface. This one, this one, this one, all interface it is going to advertise. Okay, so now let's do this lab. So what I want to say here, when we configure everything, we will have the route. We will have the route D is equal to 2.2.2.0. I am getting this route from the two path because both are having the same metric. If you see here, I am getting this metric, here you are getting this metric. So both we are getting the same metric, same cost, we have the same. That's why we are getting this in our routing table. Okay, that's why we are getting both route in our routing table. If anyone want to go to this network, they can send the traffic to this interface or this interface. Now, as we are saying, if we want to optimize, what we can say, we can increase or decrease the bandwidth and the delay. So we can decrease the bandwidth. When we decrease the bandwidth, we will have the change in the calculation, and this will remove, one route will remove. Or if we increase the delay, we will have some difference in the calculation, and it will delete one route. So I will show you that one. If you see here, I put the screenshot. Show interface fast Ethernet 0/0. This is a bandwidth. This is a delay we have. Now what we will do, we will write show IP route. So we are getting both route we are getting. Both route we are getting in the routing table. This one, just now what we check here, this one. This way I wrote here. But if you go in that interface and decrease the bandwidth, before what bandwidth you have 10,000, but now I make 1,000. Okay, I make 1,000. When I make 1,000, one route will remove. Which interface you decrease the bandwidth, that interface, that route will remove from the routing table. So when we check show IP route, that is removed, that is F0/0 is removed. Again, when I say no bandwidth 1,000, it will come both the routes in our routing table. And if I want to increase the delay, like I will go to that interface and I will say delay 1000, then it will, what we can say, then again it will remove one route. And if I want to bring that route, I will say, I will go that interface, I will say no delay 1000. So I will have the again that route. This method is known as, what we can say, this method is nothing but OSPF optimization, path selection optimization we are calling this method. This lab we can do in EVNG, GNS3, anywhere we can do. All comments are working here. So I already prepared here. If you see same scenario, what we are saying, we have R1 here, we have R2 here, okay, and here we have fast Ethernet 0 by 1, and another is 0 by 0, here is 0 by 0, 0 by 1, and IP schema we are using in between them is 192.168.12.0. so here will be different, and for the below one we are using the IP schema 192.168.21.0. so this will be 21.1 and this will be 21.2. So if you see here, this is a configuration, enable config T R1, this is the IP we assign, this is another IP, and the other method we use router Eigrp1 network 0.0.0. This way also we can advertise the Eigrp, but don't do this in the production network. This only for the lab purpose, because when we write this one, whatever interface you have, all interface it will activate the OSPF. Means if you enable this one, later someone assign some IP to some interface, automatically OSPF is going to, Eigrp is going to activate in that interface. So what we need to do, when we are doing lab we can use this command, but in the production network don't use this command. And here also what we done here in this one, we assign this IP, we assign this IP, and we created one loopback 2, and we done the Eigrp configuration. After that, when we check, we are getting the two route to go to the 2.2 network. One is from here, one is from here. When we increase the bandwidth, when we decrease the bandwidth, this route will remove. Again, when we say no bandwidth, means we have by default whatever value, then this both will come. And if we want to remove, we can go in that interface and we can increase the delay. When we increase the delay, again it will remove this route. So we will check now. Let's go here. I will copy this configuration directly, we can paste, and I can share this file, so from there you can use this configuration in case if you want to do. I think we copy paste before, or let me copy paste here, maybe just now we copy paste here. This is a R1 configuration, and this one I will copy and paste the R2 configuration here. R2 configuration, let's go here and go here, and I will paste the R2 configuration. Maybe before I paste the already, anyhow I paste here, and now I will go here in this R1, and now I will check here. I will write here show IP route Eigrp. Okay, so if you see here, I am getting the route from both, from this path as well as from this path, both. So they will do the load balancing, they will send the traffic from here as well as the here. But example, if you want to optimize this one, if you want to delete one route, example if you want to delete this one, so what we will do, we will go to that interface fast Ethernet 0 by 0, and we will write here bandwidth, and I will decrease the bandwidth. I will say 1000. When I decrease the bandwidth, you can check here, like I can do show IP route Eigrp. Okay, when we write here, that one remove from the routing table. So what we done, optimize, we optimize that one, we optimize that route, this one, path selection optimization. So example, if you don't want to optimize, you can bring also. How we will bring, just we need to write here Control A and then write no and press enter, and then you can check that one, it will come again. So this way we can optimize also, we can play with that one depending upon the requirement what you need to do. So we will write do show Eigrp. So now you have both route. And now example, if you want to increase the delay, so we can write delay, and here maybe I will give as a 5000. Okay, let me increase 5000. And now if we check here, that route will go again. Let me write here this one. If you see again, that route go from the routing table E0 by 0. If you want to bring back, right here no, here Control A and then type no and press enter. So this will go back, and we can check. How we will check, do show IP route Eigrp. So now we have the both route. This method is known as path selection optimization. change EIGRP matrix by multiplying the bandwidth or delay value. So if we decrease the value or increase the value, it will affect the changes. And if you see, before we are getting all, but when we play with that one, it will remove. So here I wrote that one. So this is known as what we can say optimization, EIGRP path optimization. After that we have the hello packets. Like same in the OSPF we have, here also we have different packets like hello, update, acknowledge, query, reply. So this one we are going to discuss in our next class. After that we will check the packets also, different types of packet, and after that we will discuss what is like we are saying FD, that is feasible distance, what is total distance, and what is successor. As we are saying, successor is nothing but best route. If I want to go from here to here, what is the best route? That is nothing but successor. And feasible distance is nothing but total distance. If I want to go from here to here, what is the total distance? That is known as feasible distance. Feasible distance, successor is nothing but the best route. So we are going to discuss this in our next class. So we will do from the packets. After that we will do the successor and the feasible distance, and after that we will do the one lab, and then we will do the summarization. After that we will do the summarization, manual summarization. We will check what is the difference between auto summarization, manual summarization, and after that load balancing, equal cost load balancing, unequal cost load balancing. Then we can finish the EIGRP. So maybe next class or after that class, maybe more to class, we can finish the EIGRP.